Hey there, pre-calc friends. This is a video that's going to help you prepare for the upcoming quiz on sections 3.3 and 3.4. Section 3.3, if you remember, was the log laws, expanding and condensing log expressions. 3.4 is all about solving exponential and logarithmic equations by usually switching from one form back to the other. And we also included compound interest money problems in there as well. So my goal in this video is to go through a couple problems with you, find a couple of similar type problems on different pages that you can try on your own. And this entire packet has been uploaded onto RadarNet on the quiz page and includes an answer key on the back. So let's start from review 1, question number 1. All right, this is one that's going to be used and done without a calculator. There'll be many problems on the quiz that you can use the calculator and many that you can't. So reading the directions really carefully will help you determine which ones you can and which ones you can't, and therefore what type of method you use for this. Now, this one here comes from our bonus log law that says, if you have an exponential expression, b raised to the, and the power that you're raising it to is a logarithm of the same base as your exponential base, then those are basically opposites of each other. Raising to a power and the power is a log of the same base basically annihilate each other, and your answer is just x. So whatever is left over after all that is just the answer. So let's look over here in this question. We have 8, and it's being raised to a log. So right away I see 8 raised to a log, and it's raised to a log of the same base, both 8. Those are opposites. So they annihilate each other, and your answer is just 5. And that's as easy, but you have to remember that log law. Are there any others like that on these other pages? Let's kind of scan through. Oh, here's number 1 here. This is another great one. This one's a little bit different though. Let's do the check. Ready? Base of 7, and it's being raised to a power, and the power is a log of the same base 7, so they should annihilate. But I'm going to tell you right now, the answer is not 3. So can you figure out what is different between this number 1 and the previous number 1? And if you can spot it, it's this right here, the -2 in front. So we're going to have to use one of our famous log laws that says if you have a number in front of the log, it came from an exponent inside the log. So let me rewrite this one. This is going to be 7 raised to the log base 7 of 3 to the -2 power. Now this is looking pretty good. All right, base matches base. There's nothing in front of the log here. So bye-bye, bye-bye. And your answer is 3 to the -2, which you can write as 1 over 3 squared, or 1/9. All right, so using that bonus log law is really useful and very quick as long as you remember that law. Any others like that? Yeah, this one's really good too. I'll let you try to figure this one out. But again, notice that this is raised to a log, but this is an ln. Remember the base of an ln. And also there is a number in the way here, so see if you can deal with that. All right, I'm gonna put check mark. That's one that you can try on your own, on your time. All right, let's go back to review 1. How about number 2? We'll see lots of problems like this in the quiz, and I'll probably say something like condense into a single log. So basically we're going to do the reverse of the log laws and try to go backwards and smash this into a single log. All right, so what we prefer to do is we see there's a plus sign. So I remember in the log law, if it's a plus sign, that means it must have come from multiplication. But before we do that, remember we have to move the exponents back as exponents. So are there any numbers in the front? Oh yeah, oh yeah. So let's move those back as exponents on these terms. All right, so right now I have log base b of u to the 2 plus log base b of v to the 3. And you can kind of go back and be like, oh, you know what? If I use the log law, the 2 would have gone in the front, the 3 would have gone in the front. So I feel like my step makes sense. All right, now I think I can smash them together. We learned that 2 logs being added smashes into one single log of the 2 inside arguments multiplied. So this becomes u squared times v cubed. And that's all we can do there. That one's all done. So smashing them or condensing them into one single log is our goal, and we did it. Any others like that? I'm sure we'll have a bunch. Oh, here, number 3. Number 3 is a good one. write as a single logarithm, or again, I might say the word condense into a single logarithm. All right, so I see a plus sign, so again, I'm going to change that to multiplication, but let's see if we have any exponents that we can move first. Nothing here in front of the log 4 or ln of 4, so that's fine, but there's a 2 here, so I can move that here. I got ln of 4 plus ln of 3 squared. Well, actually, I know that number, right? That's ln of 4 plus ln of 9. All right, and now we can smash them. That smashes into one single log of 4 times 9. And again, this is stuff that we can do without a calculator. That becomes ln of 36. All right, any others like that? Let's see. Yep, here's some more. So I'll let you try number 2 over here on your own. That's another really good one. Remember what happens when you subtract? How does that go backwards? Any others? No, that's pretty good. So that's another type that you have to sort of smash them and do the log laws backwards. Number 3 here is the type that we don't do anymore, so you can completely skip that one. And similarly, I'm just going to skip ahead on review number 2. If I go all the way down to the bottom, another similar one is number 4. Scratch that out. We didn't learn that one, so you definitely won't see something like that on the quiz. All right, number 4 is a great one. It's a money one, and we'll see a couple of the money ones on there as well. This is more of a setup, a little bit more of an algebra, and definitely using your calculator. All right, so we're depositing money. We're going to start with $1,500, and it's earning 3.5% interest rate. It's being compounded monthly, and the big question is how many years? And again, that variable is always the t variable that we have to solve for. We're going to try to figure out until the money triples. Now, what does that mean? I started with 1,500, and if it triples, that means I'm going to be left with 3 times that, or 4,500. So how long does it take to start from 1,500 and end with 4,500 under that rate and that compounding interest? All right, this is compounding monthly, which means it's our old original formula. So why don't we start with that? I have P of t equals P0, 1 plus R over n to the nt. So bring back those equations from the first quiz of this chapter. Now, P of t is the money that you want to get at the end. That's your 4,500. P sub 0 is the starting amount. And we have 1 plus. Your rate is 3.5, but remember, we have to rewrite that as a decimal, so we're going to move it 2 times to the left. How about 0.035? And this is monthly, which means I'm dividing by 12. I'm going to raise it to the 12t. And t here I'll put in red because that's the variable we're looking for. So everything's been plugged in. Everything looks great. The only variable that we need there is t for time. All right. So now what we're going to do is we need to try to figure out what is the base, because we are in exponential and our big goal is to change this eventually into a log. A log helps us solve exponentials. But the thing that's kind of tough here is what's the base? Because I need to get the base all by itself. And we talked before, the base is this whole parenthesis that's being raised to the 12t. So to get that by itself and change things in the logs, the first big step was we divided the p sub 0 first. So divide both sides by your starting amount. That gives me, all right, 4,500 over 1,500 is basically 3. 1 plus 0.035 over 12 to the 12t. All right, now that base is all by itself here. That's great. So now, why don't we change this into logs? Here we go. This becomes log base, well, that gross base that we have there, 1 plus 0.035. So that's a really tiny subscript. It's hard to see it, but it is a very, very small subscript. Just like up here, this little 5, it's supposed to kind of represent that. It's just such a big base, it's kind of hard to look at. And then what are we taking the log of? We're taking the log of 3 equals, on the other side, I should get 12t. And again, you can double check that. Remember using the arrows from before, we said base raised to the equals. Yep, and that's what we had over here. So we're right. Awesome. All right, so we're going to have to put this thing into the calculator. We're using our log base button that we talked about. And then last step is going to divide both sides by 12 to get t. So this just becomes a little bit of practice with calculator. But what I would do is I would start with a big parenthesis here, and then use your log base button on the calculator under math. In the little subscript there, use a little parentheses and just type that in. It fits fine. After you put the 3 in, close your parentheses, and then you can divide by 12 in the same statement, and it should work out fine. And if you do it right, you should get the fact that t should equal about 31.4, and this is in years. All right, there'll be 1 or 2 problems like this on the quiz, and they're not terribly difficult. They just take a little bit of practice. So hopefully this video helped with that. Any others like that? I'm sure we have a bunch here. Let's see. Yep, here's a good one. Number 4, here's another good one where you're depositing that much. There's another great one here. This one's good because it's continuously. So that's great because you're going to use a different formula just to remind you. P of t equals p sub 0 e to the RT. But again, you're still solving for t. Any others? No, that's about it. Okay. So I feel like I've done a lot from review 1. I'm going to move away from review 1. Try a little bit of review 2. All right, review 2. This is a great problem. We'll have a couple of these on the quiz too. This could be something like expand or write as a sum or difference, but basically we want to use the original log laws and start splitting this into separate logs, depending on what we see. All right, let's take a look. What's inside this log? Okay, first of all, I see division. So I'm going to remember, oh yeah, division was log of the top minus log of the bottom. Okay, I remember that. And then I also see the fact that there are some powers, and we learned that the powers go in the front of the log. So I guess the important question is, which one do we do first? And if you look at the big picture here, the most outside thing happening is the division. So we're going to deal with division first, and then after that, we'll deal with our exponents. All right, let's give it a shot. Okay, we learned that division splits into 2 logs being subtracted. That's log base b of the top minus log base b of the bottom. All right, good first step. And now powers, we learned that the powers can go in the front. That's another one of our great log laws. So I should get 4 log base b of r minus 2 log base b of s. Looking to see, is there anything else we could move here? And no, that one's all done. Number 1 is good. So again, the instructions will say expand the log expression, write as a sum of differences, because what we did here is we just wrote it as a difference of logs. So they all mean basically the same thing. Let's see. I'm sure we have a couple more of these. Let's see. All good ones here. And expand. Oh, yeah, number 1's a really good one. I like 1 here. That's a pretty good. Let's play with this one here. All right, so I see powers. I see a square root. What the heck? Ooh, and I see, it's not really written in there explicitly, but there is times going on, so that is a product. That's going to be important too. So again, let's step back for a second and think, what is the most outside thing happening here? And it's the product. So why don't we split this into 2 logs being added, and then we'll see where that takes us. All right, let's see what happens. So first of all, we have log of x squared plus log of root x plus 5. And why is it plus? It's because there was a times here. 1 log of multiplication splits into 2 logs being added. All right, so now let's see what we can do. I think we can move this power over here. And I want to deal with this, but I'm trying to remember, what is that square root? Because I think, isn't that a power? Wait, wasn't that x plus 5 to like the something? What was the power for a square root? Ah, yeah. It was the 1/2, right? Okay, so here's what I'm going to do. Let me rewrite that, because now I know it's a power. I can move that power too. So don't forget, the square root is 1/2 power. The cube root is 1/3 power. So now that can join the ranks of, all right, toss in front of that log. Toss in front of that log. So here's what we got, folks. We have 2 log of x plus 1/2 log of x plus 5. This x plus 5 here, I feel like I could do something with it, but there's no log law for that. It has to be either multiplication or division, and it's just addition. We don't have a log law for that. So believe it or not, we are done. There you go. That's, again, either expand the log expression or write as a sum of difference of logs. Same idea. Any others? Yeah, here's another one too, number 2. Same idea. This is expanding or write in terms of, but basically, can you take this expression and break it down? Ooh, there's that cube root, right? So just to give you a hint, I would rewrite the cube root as a 1/3 power. Because now that you did that, do you know where that 1/3 is going to go? Remember that log law? Okay, good luck. That's a great one to try. Any others? No, that's pretty good. All right, let's go back to review 2. How's your brain doing? You doing okay? Good, mine too. How about number 2? Let's solve for x. All right, now we're getting to section 3-4. We're solving equations. Now, sometimes you'll have a calculator, sometimes you won't. And if you don't have a calculator, it's exponential. This is the type where you want to match bases. If you can't use a calculator, you're probably meant to match bases. And you'll be given numbers here, bases, where they are multiples of each other. Like I know 125 is related to 5. It's like 5 to the something. Another clue that I see here is that both sides have an exponent. We don't usually have that on the ones that have calculators, right? Like this is going to be a calculator one. And look, only this side has the x exponent. Is there another one like that? Oh yeah, here's another calculator one. And look, only this side has the x exponent. So that's a good clue that if you see both sides have the x as an exponent, it's probably going to be a matching base one. All right, and the trick is take the bigger number and rewrite it in terms of the smaller number. So what is 125 in terms of 5? And I remember that it is 5 to the 3. Now x is still on the outside because remember that whole thing was 125 to the x. So I have 5 cubed to the x, and over I have 5 to the 2x minus 3. All right, the bases are almost the same, but you know what? I'm going to clean up this left side. Remember, if you have a power raised to another power, you multiply them. Just our properties of exponents. All right, now look. Now we have base equals base. And if the bases are equal, well then, the exponents are equal. So now we can set up a whole new equation of now 3x from the left side exponent equals 2x minus 3 from the right side exponent. So once the bases match, the exponents match, and you can solve that equation. All right, I'm going to subtract 2x from both sides, and I basically get x equals -3. Let's find more like these, where it's a solving exponential, but it's without a calculator, because that's a good clue. Let's see, exponential. No, not this one over here, right? Because that was the special log law. I'm not seeing over here. Okay, maybe we have another one. Oh, here we go, number 1. Yep. So solving exponential, but without a calculator. So try to rewrite it. And try to rewrite it so that they match the bases. Remember, 9 is something in terms of 3. This is a good one because just looking ahead, I noticed an x squared. Remember from your algebra days, a lot of times if you have to solve an x squared, don't forget you're probably going to have to factor. So factoring is big on this quiz. Factoring is big in pre-calc. So don't forget about that one. I'll leave number 1 for you to try. All right, back to page 2. Did we cover everything? Yeah, we crossed out number 4. All right, we only have a little bit more left because then they keep repeating. So we left that for you. Now, number 3. What if we had an exponential and we get to use a calculator? And obviously you can tell here, I can't rewrite e in terms of 22 or vice versa. It's just weird. Like, because that'd be more obvious for us to match bases. So this is the one where you want to eventually change into log form. But first, let's make sure our base term is all by itself. Is it alone? And it is. If it's not, we're going to have to try to get it alone before we turn it into log form. But now it is alone, so yay, we can switch it into logs. Here we go. Now, the base here is e, which means our log is going to be an ln, a natural log. And this is going to be ln of 22 equals 3x plus 4. If you want to use the arrows to double check if that's right, but I think we're right. I think we're good. Now, ln of 22, that's just a number. So I can put that in the calc, but I think I want to solve for x first. So I'm going to go ahead and subtract 4. This is ln of 22 minus 4. Remember, you can't combine these. Don't do that. The 22 is inside the log. The -4 is outside the log. So no touchies. Don't do that. Okay, that becomes equal to 3x. Last step, we divide by 3. Okay, so now x should be equal to this. You could just put it directly into the calculator. Maybe open some parentheses. Parenthesis, ln of 22 minus 4, close parentheses, divide by 3. And if you do it right, this is on example 3 on review 3. I think my x number is about -0.3 or 30. Again, a lot of these are 2 decimal places, so that'll help us for our rounding. Okay, so exponential, we generally want to get into log form. Make sure the base term is by itself before you change it, and you're good to go. Let's find one more like that. Oh, here's another good one here. I'll make some space here. This, again, is an exponential, and it says 2 decimal places, so that's definitely a calculator. All right, let's check and see, where's the base? Here it is. Okay, is the base term by itself? Yes. Now, just for the heck of it, can I look around for a sec? Are there any of them where the base term is not by, oh, look at this, number 3. All right, can you spot the base? And can you see at the base, and the base term is not all by itself? So some of these will have to do a little bit of algebra first, like get rid of that 4. Divide it, before you start doing log form. So don't jump into log form. Oh, here's another good one. There you go. So before you change in log form, make sure you get the base and the base term all by itself first. All right, let's go back to what I was doing before. How about this one? It is by itself. That's good. So let's switch into log form. This is log. Base 7 of 15 equals 3 minus 2x. Cool. So switching back and forth between log and exponential is really, really useful. And let's just do some algebra. I'll subtract 3. I get basically -2x equals log base 7 of 15 minus 3. Can divide by -2. X equals, okay. Again, if you want to put this in your calc in one movement, this would be parentheses first. Use the log base button. When you use that, it opens up a little mini parenthesis for the number inside the log, not the subscript, but the number inside the log. Once you're done with the numerator of the fraction, close it, and then you can hit divide by the -2, and it should work out. And if you do it right, review for number 2 should be about 0.80. Great. And again, like we said also in class, if you want to, this is algebra. Whenever you solve an algebra, you can always check your work by plugging in. I would definitely do that on the quiz. So meaning I would say 7 raised to the 3 minus 2 times your x value that you found. So plug that into your home screen, and you want to get it as close to 15 as you can. If you get something way off, that means your answer here is not correct. Or maybe you plugged it in weird, but it means that your answer is not correct, so you can go back and fix. But you should get as close to 15 as possible. All right, so any other problems like that? Yep, number 3 is very good. Excuse me. Number 2 is really good. So these are all really good practice ones where isolate the base, switch into log form. Okay, I think we're just about done here. Why don't we do a couple where we're in log form, like I can see here. And again, we can use the calculator. So when you're in log form, we're going to do the reverse. We're going to try to switch it back to exponential form. And switching back and forth just frees the variable for us so we can solve it. All right, like before, is the base by itself? But here in log form, you want to ask, is the log term by itself? And yes, there's nothing else around the log over here that we have to get rid of. Can we just take a peek? And the other ones where there is something next to the log? No, that one looks pretty good. No, they're good ones. But just watch for that. If you want to pick some from your homework or your notes, I know we've done a couple where there is stuff outside the log. So practice that because you might see that on the quiz. Okay, so again, the goal is, let's switch this into exponential form so we can solve for x. Now, what's our base here? It's empty. So it's 10. Remember our arrows? 10 to the 2 equals what's inside the log. Great. Now the x is free and we just need to solve for it. All right, 10 squared is 100. equals 2x plus 5. And then just doing algebra, we're going to subtract 5, and then we're going to divide by 2 when we're done. So 100 minus 5 is 95, divided by 2. And actually, that's a fine answer if you want, because there's not much you can do to that. Or you can say that's 47.5. Both answers are great. Okay, so log form, switch it into exponential. Let's try number 3. All right, number 3, we're going to check again. I'm going to go into exponential form. Is the log term by itself? And it is. There's nothing else around it. So good. We're good to solve for it. Remember, the base of ln is e. So we have e to the 3 equals what's inside. Great. Now, e to the 3 is just a number. We can put that into our calculator. So let's do some algebra here. We're going to add 7 and divide by 4. So just to save a couple steps, my x should be e to the 3 plus 7 whole thing divided by 4. And again, if you want to put in your calculator in one big step, just surround the numerator by parentheses, and you should be good to go. Remember, e to the is second ln. It's right up here. It's the e to the x button. So you can plug that in, push that button, second ln, put in 3, you should be good to go. And if we do this at 2 decimal places, this is review for number 3, you should get about 6.77 to 2 decimal places. Good. Any others like that? Here's an exponential for 3. And here's another log one for number 3. That's both good. All right, I think we covered everything. Let me just do a quick check with you to see. I think we covered every different type. So back to the beginning, really quick, folks. What are the different types we're going to see? All right, let me clear all this ink. First of all, how about just using the bonus log law, where if you see a base raised to a logarithm exponent, that's the same base, they basically annihilate each other, unless, where'd it go? Yep, unless, like here, number 1, you see something different, something in the way, then you have to do a little algebra first. There'll be lots of log laws where you have to either condense it into one log or split it into separate logs. So going one direction and going the other. We'll see lots of that. We said number 4 we're not doing, and number 3 we're not doing. And then we get into 3, 4. And 3, 4 is solving exponentials, either solving it without a calculator, which means, again, matching base. And if you can match the base, then the exponents are equal. Or if you can't match the base, you're going to see the instructions say solve it to 2 decimal places, and you're going to try to use log form here, switch into a log. And then the verse was, if we had a log expression and we're using calculator, can we switch it back into exponential form and put in the calc? And then the last type of question are the money ones. And those are kind of tricky, but after you do a couple, they're really not too bad. Just make sure you know which equation you use, whether it's continuous or not, and just get really savvy with your calculator. It should be good to go. All right, pre-calc friends, I think we covered a little bit of everything. Hope this video helped. And if you have any questions, just holler in class or I'll see you next for help. Awesome. Good luck, folks.